Hello everyone. So our today's lesson is about setting up the camera and making a vision inspection process. So the main objective of our today's class is to trace this item by using this camera, okay, and identify the dimension of this item so that it is going to be passed or failed. In our today's lecture, we will basically trace this item, okay, or we will find this item using this camera, and we will make some inspection vision process to identify this item and do a pass fail inspection. Okay, so in order to do this pass fail inspection, we will need to identify the dimension of a certain features on this item, and we will inspect the dimension and identify whether the dimension falls within a specified tolerance limit or not. If the dimension falls within the specific inspection tolerance limit, then the item will be passed, otherwise it will be failed. Okay, so today's lecture is about inspection vision process. So the first thing I want to show you is the camera. As you see here, the camera is mounted on the ceiling here. Okay, and we need to remove the cap of the camera. So the camera is here. Okay, so now I'm going to turning the machine on, and we will do our work using this stitch pendant today. So once we have this stitch pendant on and our machine is on, then we need to click on this menu button, and we need to move our cursor to find iRVision. Okay, and we are going to find the iRVision setup. And now we are going to click on this create button. Okay, either here or F2. So first we will set up our camera. So I'm selecting this 2D camera. Okay, press on this button. So the first thing I need to do is to write a name of this camera, and then I'm going to give a name to it. Camera 1. We have only one camera, so it doesn't matter. And we can write some comment here. Test VIS test vision process. Test inspection vision process. So that's just a comment. Okay, and press and OK. So the new camera is ready to set up. So I'm going to click on this edit button. Okay, so the first thing I need to select the camera. We have only one camera here, so click on this camera button. The camera will capture a picture of this grid. Okay, Now I'm going to change this exposure time to find the picture in a better quality. That's nice. So let me show you, this is our grid. So you will use this for calibration, and it has 15 millimeter center to center distance from one dot to another, and these three dots indicates the x-axis, and these two dots indicate the y-axis. Okay, let's come back here on the screen. Then the second question is whether the camera is robot mounted. No, this is not robot mounted. Calibration, grid pattern calibration. Now I'm going to click this calibration button. I'm just going to make it very quick. Grid calibration 15 millimeter I have. Number of planes only one. Grid calibration, perspectives, and now let's click on set and find. So I'm just keeping all the dots inside the area, selection area. Okay, let's see. Yes, we got it. The calculated focal distance is 13.31 millimeter. That's nice. 13.31 millimeter, and it is set. Now I can save it. Save. Okay, and end. So my camera is now set. Okay. So now our next target is to make a inspection vision process basically. So inspection vision process is a cost-effective approach to check the presence or absence, or find the orientation, or verify some critical features of a part. So here is our part. We will do our work on this part. And it requires no calibration basically, and does not return any part offset that can be used to modify the robot movement. It does, however, return a pass or fail dependent on criteria set by the user. Okay, we will do some dimension setup that will determine whether the item will be passed or failed. So as I mentioned, many tools may be used in conjunction with the inspection vision process. Okay, now let's start with the create button. This create, if you want, you can click on this F2 button. That will also work on clicking by here, create. And now I'm going to find single view inspection. Here I got it highlighted, single view inspection vision process. Now press this enter button. Now I need to give a name to this vision inspection process. Let's say inspection 1. I'm going to type some note here. This is test of inspection process. Okay, so the name and comments are added. Now click on OK. Okay, this is ready to do our inspection vision process. Once ready, you can click on edit button. The first thing it will ask for the camera name. We have already set up our camera, so this is camera 1 that we have. I can place the item here. I can put it here like this and click on this snap button to see if it is visible. Yes, it is visible. One more thing I want to do here, I'm just going to click this measurements in millimeter. Okay, and then grid spacing 15 millimeter. Sorry, this needs to be 15 millimeter. Another thing I'm going to do is to change this to yes, and the focal distance is 13.3 millimeter. Then I'm going to place this grid under the camera again to do the training. Come here, because the grid is located on the base, we don't need to change this height from the plane. This will remain, this one 0 0 will remain 0 0 millimeter. Now we need to take a snap again, because now we have changed the item under the camera, so we need to take a snap again and then train. We need to find out the points within the area. So I'm going to placing this area over the grid. Okay, click on OK. It says the scaling data has been calculated, so click on OK. So we have found a scale conversion factor. Okay, once you are done, click on save. Okay, now click on these trees and click on this plus button. As you see, plus. It will bring you to this create a new vision tool. Okay, now once you have this screen, we are going to find the window shift tool. So scroll down and find window shift tool under the others category, window shift tool, and press on enter. Keep the name as it is, window shift tool 1. You can change the name if you want. Click on OK. Now a window shift tool is added to your process tree. A window shift tool brings with it a GPM locator all tools after the window shift will be viewed as relative to the GPM locator, even though they are taught as children to the overall single view inspection process. So click on that GPM locator tool. Then remove this grid and place the item under the camera, and then take a snap. So move this and snap. Now click on this stitch button, stitch. Size the box to enclose any features that you want vision to find. And so once you are done, click on OK. As you see here, we found the edges that is outlined with some green lines. To test the system is able to locate the part, press the snap button and then find button. Okay, it's finding the item very nicely. In order to mask out undesirable features, press the edit under the training mask. As you see here, training mask. Beside that you will find the edit button. Click on that edit. Now I am going to use this draw tool to mask out this circular feature here and here and anything here. I'm just going to mask out. Okay, so similarly draw over the undesirable features with the draw tool of your choice, and when you are done, click on OK. So once you have these, you will see the mask out areas will be identified with some red color. Okay, now click on this tree tab and then choose the single view inspection process. Okay, click on this single view inspection process and then click on new file folder. Here as you see the plus sign. Okay, now I'm basically looking for S pair locator tool here. As you see the S pair locator tool. Now click on OK, I mean enter. The name, you can change the name if you want. I am just keeping it as it is, S pair locator tool 1. So click on OK. Okay, so now the S pair locator tool is added to our process tree. Now go here and press on this set button, and I'm going to zoom this 200% so that I can see the feature. This internal rectangular area is my interested area, so bring that box near to the internal rectangular area. Okay, now once ready, click on OK. Let me make it a little bigger and click on OK. Now teach. As you see, two green lines, that is the reference lines. So I want to make these lines closer to my indicator. Now train these edges for measurement. If we need, we can make it more bigger even. So let's make it 400%. Precisely placing those two edges of my indicator on the green lines. Once done, click on OK. So thus the trained edges will display here. Now to test the ability to measure the edges, first press on snap and then click on find. Yes, it is indicated with green indications that it can measure the edges correctly. So now press this next button and save. Now go to this tree again and then click on this evaluation tool 1. Okay, click on the variables. Okay, now selecting this v1 variable 1, click on this S pair locator tool 1, that is only variable we have created so far, and here select the length. Okay, then go to the conditions. Okay, under this condition, click on the first condition C1. Okay, and let's make it the variable we have v1, just to declared variable, and then the condition will be within in condition. Let's measure the dimension here. So let's see, this is 15 millimeter, so let's make the range 13 to 17 millimeter. Okay, so the first one was 13, 17, enter. So this is the condition 1, variable 1 will be needs to be within 13 to 17 millimeter. Okay, now save. So this is now saved. So in order to test the overall process with the single view inspection, we can highlight this single view inspection this process, highlight that one, and then snap and find. Okay, this feature will show pass or fail. It will display the item either passed or failed. If we just displace this item little bit and do the same thing again, snap and find, yes, it is passed. In order to view the detailed results data, you can press on these results and see the actual value. As you see, the actual value is 14.569 millimeter and our range was 13 to 17 millimeter, so that is within the range, so the product passed. we can write a simple program to check this pass or fail results. So in order to write a program, we can click on select, okay, and create. Let's make a name, test 90, enter. So now you can make a program to check the pass and fail options. Click on instructions and then vision process. First we need to select this run find, and choice is the inspection one. We have just created the inspection vision process, and in the second line do the same thing, vision. This time we will select the get pass fail result, okay, and choose inspection, and we will store the result in, let's say, register 5. We can run this program. So program ran. Now the results are basically stored in register 5, as you see here, register 5, but the results can also be viewed on the runtime screen. So let me find the runtime screen. Here, vision runtime, as you see here, this is passed. Okay, now I can move this item in a different place, okay, and I can run the program again to see if the item can be detected. You see here, item is passed, but if I just remove this item and place something else, let's say something else here, and then run the program again, as you see, this is undetermined or failed, and I'm going to place the item again, but in a different orientation, okay, totally different orientation, and run the program again. You see, passed. Okay, so that is how the inspection vision process works. And I want to mention one more thing. If you cannot find the part while testing, you can check the contrast and decrease the threshold value in GPM locator tool, and also S-pair locator tool. Okay, so I mean that you sometimes it happens that the light intensity is not suitable, so you need to adjust the contrast and the threshold values. All right, so that's the end of my lecture today. Have a nice day.